Now next topic is distance between two parallel lines. Suppose that two lines are r bar equals to vector a1 plus lambda into vector b, and second r bar equals to vector a2 plus mu into vector b. Now these are two parallel lines. Then distance between these two parallel lines is given by d is equals to in mod vector a2 minus vector a1 cross vector b upon magnitude of vector b. So this also can be written as vector a2 minus vector a1 cross b bar upon magnitude of b bar. So this is unit vector, so we write this in this form also, vector a2 minus vector a1 cross b cap. So by using this formula we can find the distance between two parallel lines, that is shortest distance between these two parallel lines. In class 10 or in class 11 we discuss about Cartesian form. If the lines in Cartesian form, we find the shortest distance between two lines. Here we consider vector form. Now see first example from exercise 6.2. Find the length of perpendicular from 2 minus 3 1 to the line x plus 1 by 2 is equals to y minus 3 by 3 is equals to z plus 1 upon minus 1. So we know the formula for vector form. If P of alpha bar is a point, we have to find the perpendicular distance of this P of alpha bar from the line. If P of alpha bar is a point and r bar is equals to a bar plus lambda into b bar be a line, then perpendicular distance of P of alpha bar from r bar is equal to a bar plus lambda into b bar is under root alpha bar minus a bar its magnitude square minus alpha bar minus a bar dot b bar upon magnitude of b its square. So by using this formula we can find a perpendicular distance of a point to the line or from a line. So we reduce this form into vector form. So here this 2, 3, minus 1 are the direction ratios of a line parallel to the given line, and this line pass through the point, because this line we write in the form x minus minus 1 upon 2 is equal to y minus 3 upon 3 is equal to z minus minus 1 upon minus 1. That means the given line passes through the point minus 1, 3, minus 1. So we write here, therefore the given line passes to the point minus 1, 3, minus 1 and parallel to the vector. So parallel vector we can find from this direction ratio 2, 3, minus 1. Given line passes to the point minus 1, 3, minus 1 and parallel to vector. Suppose b bar equals to 2i plus 3j minus k. So we first find from which point that line passed. So from this point we can find position vector of a point. So we write therefore, or we can write here, the given point passes to the point a of minus 1, 3, minus 1, therefore a bar is equals to minus I plus 3j minus k be the position vector of point A. Now this point 2 minus 3 1 is point P here, that means value of alpha bar we can write from this coordinate. So we write here alpha bar is equal to 2I minus 3j plus k. Now we find alpha bar minus a bar first. So we find alpha bar minus a bar is equal to alpha bar is 2I minus 3j plus k minus a bar is minus I plus 3j minus k. This is equal to 2I minus minus plus, so 2I plus I, that is 3I, minus 3j that is minus 6j, then minus minus plus k plus k, that is 2k. Now this is value of alpha bar minus a bar. We require the value alpha bar minus a bar its square, that means magnitude of alpha bar minus a bar. So we first calculate the magnitude alpha bar minus a bar, therefore magnitude of alpha bar minus a bar is equal to, so we write here 3 square is 9 minus 6 square is 36, 2 square is 4, so we get here in root 49. Now we require the value of its square, so we take square on both sides, so we get here 49. Now denote this as equation number 1. This is equation number capital A. Now again we have to find value of alpha bar minus a bar dot b bar. So first we calculate that value. Alpha bar minus a bar dot b bar is equal to alpha bar minus a bar, we calculate 3I minus 6j plus 2k dot b bar is 2I plus 3j minus k. Now 3 into 2 6, so we get 6, minus plus minus minus, so we get minus 18, then 2 into minus 1 we get minus 2. So here minus 18 minus 2, that is minus 20. Minus 20 plus 6, so we get minus 14. So we know this as equation number 2. Again we require magnitude of vector B. So we calculate magnitude of vector B, then we substitute these values in equation number capital A. Now magnitude of vector B we calculate from this vector B. So write in root 2 square is 4, 3 square is 9. Minus 1 square is plus 1, so we get here square root of 14, that is magnitude of vector B. Now substitute from equation 1, from equation 2 and from equation 3 value of magnitude of alpha bar minus a bar its square, alpha bar minus a bar dot b bar upon magnitude of B. So we write here, put in equation capital A. Therefore we write here alpha bar minus a bar its square minus alpha bar minus a bar dot b bar upon magnitude of vector B its square is equal to. Now substitute the value of magnitude of alpha bar minus a bar its square as 49. So we get here 49 minus, in bracket we calculate this dot product from equation 2, we substitute that value as minus 14 upon this magnitude of B, we calculate square root of 14 its square. Now we have to write 49 as it is minus square of 14, so we write here plus 14 into plus 14, we know that square is always positive, upon this square square of root 14, we write 14 because square and square root get cancelled. So this 14 get cancelled. We get here 9 minus 14. So in this way we can calculate the value of distance of a point to the given line. So 9 minus 4 we get 5, and this 4 minus 3 we get 35. Now see question number 2. Find the coordinate of the foot of perpendicular drawn from the point 2I minus j plus 5k to the line r bar equals to 11I minus 2j minus 8k plus lambda into 10I minus 4j minus 11k. Also find the length of perpendicular. So we first draw here diagram figure for solution of this second problem. Now here P of alpha bar. Now here foot of perpendicular from the point, that means value of alpha is given, that is 2I minus j plus 5k, and we have to find foot of perpendicular. That means when we draw a perpendicular from P to this line, that means this M is the foot of perpendicular. We have to find the coordinate of point M. Now this point is on this line, so we consider this r bar as any point. So we write this as xi plus yj plus zk is equal to 11I minus 2j minus 8k plus lambda into 10I minus 4j minus 11k. That means coordinate of any point, we get 11 plus 10 lambda I, then minus 2 minus 4. So we write here in bracket minus 2 minus 4 lambda j, then plus in bracket minus 8 minus 11 lambda k. That means here coordinate of any point, that is suppose point M has coordinate 11 plus 10 lambda minus 2 minus 4 lambda minus 8 minus 11 lambda. So we have to find the value of lambda and substitute that value, we get the coordinate of point M. So we write here, let M be the foot of perpendicular with coordinate 11 plus 10 lambda minus 2 minus 4 lambda minus 8 minus 11 lambda. Now this PM is perpendicular to this line, and this line is parallel to this vector, which we consider always vector B. So B bar equals to 10I minus 4j minus 11k. Now we can find the vector PM. Once we know the coordinate of point M, which we write here, we can find vector PM. Vector PM equals to, so we write this position vector of M minus position vector of P. So from this we can say 11 plus 10 lambda I minus 2 minus 4 lambda j minus 8 minus 11 lambda k. These are the position vector of point M. So we write here 11 plus 10 lambda I plus minus 2 minus 4 lambda j plus minus 8 minus 11 lambda k minus position vector of P. So we write this as 2I minus j, 2I minus j plus 5k. Now therefore we write here 11 minus 2, that is 9 plus 10 lambda I then minus 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 plus j, so we write here 2 minus 1, that is 1, so we write minus 1 minus 4 lambda j, then minus 8 minus 5, so we get here minus 13 plus in bracket minus 13 minus 11 lambda k. So this is vector Pm. Now this vector Pm is perpendicular to this line and this line is parallel to this vector P. So we write here vector Pm dot vector P is equal to 0. Therefore we write value of Pm and value of vector P. 9 plus 10 lambda I plus minus 1 minus 4 lambda j plus minus 13 minus 11 lambda k dot b bar is 10 I minus 4 j minus 11 k equals to 0. Therefore now multiply this with I with I, so we get here 9 plus 10 lambda into 10 plus minus 1 minus 4 lambda into minus 4 plus minus 13 minus 11 lambda into minus 11 is equal to 0. So we multiply by that to first bracket, so we get here 90 plus 100 lambda, then multiply by minus 4, so minus minus plus 4, minus minus plus 16 lambda, then minus so we multiply this minus 13 with minus 11, so we get minus minus plus 13 11 the 143, then minus minus get plus 11 the 121 equals to 0. So we add the lambda term 100 plus 16 plus this 121 lambda, so we get here 237 lambda plus 237 is equal to 0. Therefore lambda is equal to, so transfer this right hand side, we get minus 237 lambda equals to minus 1. So we substitute this lambda equals to minus 1. After substituting lambda equals to minus 1, we get the coordinate of foot of perpendicular, that is coordinate of point M. So we consider here M be the foot of perpendicular, we substitute lambda as minus 1, we get coordinate of foot of perpendicular. So we substitute lambda equals to minus 1 in coordinate of M. So we write here, therefore M is, so substitute 11 plus 10 into lambda as minus 1, minus 2 minus 4 into lambda as minus 1, minus 8 minus 11 lambda is minus 1. So 11 minus 10, so we get 1, minus minus plus 4, minus 2 plus 4, we get plus 2, minus minus plus 11, 11 minus 8, which is 3. So the coordinate of foot of perpendicular are 1, 2, 3. Now we have to find distance of a point P to the line. We have to find perpendicular distance. So you can use distance formula for calculating the value of Pm, length of Pm. So we write here vector Pm is equals to, now we write vector Pm as 2 position vector of M minus position vector of P. So 1 minus 2, which is minus 1. So we get here minus 1. Then 2 minus minus get plus. So 2 plus 1, that is 3j. 3 minus 5. So we get here minus 2k. So we calculate its magnitude, which will be the length. So in the root we get magnitude of Pm which is equals to minus 1 square is plus 1, 3 square is 9, minus 2 square is plus 4, that is square root of 1 plus 9 square root of 14 unit is the distance of point P from this line, that is perpendicular distance of a point to the line.